Assalamualaikum. So today we from Group 5 will present our parts for assignment Math 565. But first, let me introduce you to our group members. Me, myself is Muhammad HAIKAL bin Zakaria. Next, Muhammad HAFIZ ADLI bin Muhammad YASIN and YAKBAL bin Zakaria.
Assalamualaikum. My name is YAKBAL bin Zakaria. In this video, I will presenting about task 1. What is the Fourier series? The Fourier series is a mathematical tool used to represent a periodic function as the sum of simple sine and cosine function. It is named after the French mathematician Joseph Fourier, who introduced the concept. The Fourier series is particularly useful in analyzing and synthesizing functions with periodic behavior, such as waveform in signal processing. A periodic function, fx, with a period L can be expressed as a sum of sine and cosine function in the general form. A0 is the average value of the function over one period. An and Bn are the coefficients that can determine the amplitude of the cosine and sine terms, respectively. The coefficient An and Bn can be calculated using the following formulas. The terms of cos 2 pi n over L and sine 2 pi n over L are orthogonal functions, which mean that the integrating their product over one period result in 0 unless n equal to 0. This property allows the Fourier series to represent the periodic function using a combination of this orthogonal function. A Fourier series has many applications in mathematical analysis, as it is defined as the sum of the multiple sines and cosines. Thus, it can be easily differentiated and integrated, which usually analyze the function such as saw wave, which are periodic signal in experimentation. It is also provide an analytical approach to solve the discontinuity problem. In calculus, this helps in solving complex differential equation. Type of Fourier series. First is even function. How do we know that this is the even function? If you look at the calculation below, you can see that fx is equal to f negative x for both range, which means it satisfies for Fourier series property. Of even function, we can conclude that the coefficient Bn is equal to 0. Now, we move on to calculate A0 and An. A0 is 4 over pi and An is 4 over pi impurities 1 minus n squared. Now we have both of the coefficients that we need to calculate the Fourier series. By substituting coefficient into Fourier series general form, we will get the 2 over pi minus 4 over pi impurities cos 2x over 2 square minus 1 plus cos 4x over 4 square minus 1 plus cos 6x over 6 square minus 1. The second type of Fourier series is odd function. How do we know that this is the odd function? If you look at the calculation below, you can see that for both range, we get fx is equal to negative f infinitive negative x, which means it satisfies for Fourier series property of odd function. We can now conclude that A0 and An is 2 equal to 0, and we only have to calculate for coefficient of Bn. To calculate the coefficient of Bn, we have to apply trigonometric identities of 2 cos A sin B is equal to sine imperative A plus B negative sine imperative A minus B. And the final answer we get negative 4n over n imperative 1 minus n squared. By substituting coefficient into the general form of Fourier series, we get the final answer negative 4 over pi imperative 2 sine 2n over 1 minus 2 squared plus 4 sine 4x over 1 minus 4 squared plus 6 sine 6x over 1 minus 6 squared. The last type of Fourier series is neither function, because if you look at the calculation below, you can see that it does not satisfy both for Fourier series property of odd and even function. We have to calculate for all the coefficients. Coefficient of A0 is pi over 2. For coefficient of An and Bn, we have to use integration by part. The coefficient of An is negative 2 over pi squared, pi n squared, and the coefficient of Bn is negative 3 cos n pi over n. By substituting for all of these coefficients into the general form of Fourier series, we get the final answer of pi over 4 minus 2 over pi infinities cos x over 1 square cos 3x over 3 square plus cos 5x over 5 square minus 3 infinities negative sin x over 1 plus sin 2x over 2 minus sin 3x over 3.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz ADLI bin YASIN. I will explain about task 2. The Fourier sine series represent a periodic function as a sum of sine function, while the Fourier cosine series represent it as a sum of cosine function. Both series are used to decompose complex periodic function into the simpler component for analysis. I will explain this a quick glimpse because my partner already threw this. So, for the Fourier sine series, if fx is periodic function with period 2L, the Fourier sine series representation is given by the formula where the coefficient Bn are calculated. For the Fourier cosine series, its representation of fx where the formula have been given, where the coefficient AO and AN been calculated. For the Fourier cosine series, which is an even function, the function have been solved by using the method of the Fourier cosine series. To solve it, first we must make the graph, because it can prove that this is Fourier cosine series. After that, insert the formula and calculate AN and AO. And then, make the final answer by insert the value AO and AN to formula of Fourier cosine series. For the Fourier sine series, which is odd function, it's same method by using the different formula. It also function that have been solved by using method of Fourier sine series. To solve it, first we must make the graph because it can prove that this is Fourier sine series. After that, insert the formula and calculate Bn, and then make the final answer by insert the value of Bn to the formula of the Fourier sine series. For the Fourier series, which is neither odd nor even, we must calculate AO, AN, and Bn. It also same method by using the different formula. It also function that have been solved by using the method of the Fourier series. To solve it, first we must make the graph because it can prove that this is neither odd nor even function. After that, insert the formula and calculate AO, AN, and Bn, and make the final answer by insert the value AO, AN, and Bn to the formula of Fourier series.
Assalamualaikum, and today I'm going to explain about the task 3 that given. Harmonic analysis. Harmonic analysis are the sine and cosine component of a function, or in another word, the simplest function that can be decomposed into a given function. Application in real life. Frequency and amplitude are the two characteristics of tones and that define the pitch and intensity of the sound to identify the genre of music. You may study the harmonic of musical instrument, beat of frequency, and your own voice by applying the Fourier transformation to different sounds. The Fourier transform allows us to break down the time series represented by the music into the base frequency. The Fourier series will tell us how much the weight is there in the music we wish to evaluate. The basic frequency can be used to represent and classify the type of music. This is the selected function for the harmonic analysis. As shown in the data given, the value of x and y, also the a1 and b1 value, we can find the harmonic analysis. Find the Fourier series of the function in the standard form up to including the second harmonic. All the calculation must be in 3 decimal places. Based on the data given, the sum value of y cos 2x and y sin 2x can be found by using the Microsoft Excel, so that it's more convenient and time efficient. For the calculation part, A0 can be found by using the formula 1/6 sum of fx, which is the 5.82, while the C0 is the value of A0 divided by 2, which is 2.91. Then the value of C1 is determined by square root of A1 square plus B1 square by the value given in the question. Therefore, we can get the value 1.475. Next, alpha 1 value is obtained by inverse tangent value of A1 divided by B1. Based on the sign, we can identify the quadrant. Both negative sign mean it is quadrant 3. Therefore, we need to plus with 180 degree, and the value of angle obtained is 186.982 degree. Going further into the calculation, A2 can be obtained by using the 1/6 sum of y cos 2x. The value is 1.5 1/8, while the B2 is 1/6 sum of the y sin to x with the value of negative 0.422. With both of this value obtained, we can find the C2 using the same formula as C1, but using A2 and B2 value. Therefore, the value is 1.576. Next, we can get the alpha 2 with the formula tangent inverse A2 divided by B2. From the sign, we can conclude that it is quadrant 2. Therefore, we need to minus 180 degree with the value obtained and get 105.536 degree. Final answer is as shown at the slide above. We return in standard form. That's all from our group. Thank you.